All right, because a lot of students find that aspect very, very confusing. So you see the reason why you need to subscribe to this channel so as to get notification on our videos. Do well to like, comment, share, and invite your friends to also partake. All right, now moving forward, in cyclic permutation, we are looking at arrangement of objects round a circle, right? Now, in your school, you might actually come across friends, students, classmates who are discussing and then form a circle unconsciously while talking. All right? Or let me use a perfect example that you will understand. You've seen a circular dining, a dining table that has round seating. This is the table. The table looks like this with chairs round it, right? Okay, some of you have a dining in this nature, while some of you, the kind of dining you have is rectangular or another shape. Now, imagine if you have this dining, this kind of dining table. This is for your dad. This is for your mom. This is you. This is your big sis. And this is your kid bro. Now, you see, you guys are the objects round this circle. Now, in how many ways can you guys be arranged? Right? So now, the first question that should come to your mind is, if we are to be arranged on this dining, who will be the first position? Like, who will be first? Now, imagine coming to the assembly, there is a line, and then I come to the center and I say you are the first person. You will be like, no, the first person is at the front. Why? Because it's a straight line. It's easy for you to know who is the first. But in a circular arrangement like this, it's very difficult for you to say, okay, daddy is the first. Because somebody else will come and say, no, mommy is the first. Then the kid bro will say, no, I am the first. All right. So now, in arranging objects around a circle, for instance, sitting arrangement around a circle, you declare the first. Now, why are you declaring the first? Remember, we are checking how many ways can daddy, mommy, you, your big sis, and your kid bro sit around this table. In how many ways can your sitting arrangement around this circular table be made? So in order to determine it, the first thing should be who is the first person so that we'll know how to make the arrangement. Now let's pick big sis. Now, if we are saying that we are starting with big sis, then every other person will move round. It means that the position of big sis is fixed. Remember, her seat is just 1 out of 5 seats. And we want to arrange 5 of you around this circle. Now, if big sis is first, that means kid bro can be the second, daddy the third, mommy the fourth, you the fifth. Or kid bro is second, mommy can be third, while daddy is fourth. Every other person will keep moving while big sis remains where she is. Why? Because if we remove her, we won't know our starting point again. We won't know how to make the arrangement again. Is that clear? Now, we said there are 2 conditions or 2 kinds of this cyclic permutation, and that is objects around a circle, which is what I just explained. Now, what I've explained is the rationale behind this -1. You said it is n minus 1 factorial, right? Good. So that -1 is because there is a fixed person who is not rotating as others are rotating. Big sis is fixed. Her sitting position is fixed. So when kid bro is taking second, daddy is taking third, or daddy is taking second, kid bro is taking whichever position any other person in the family is taking, kid sis is the first. Her sitting position is fixed to enable the rotation or the movement or the swapping or whatever of others round the table. Is that clear? Good. Now, The second condition we said is object fixed in a ring which can be turned over. All right, and that's n minus 1 factorial over 2 factorial. So now let me explain that one. So I believe at the end of this explanation, whenever you see a question that has to do with cyclic permutation, you should know, does it follow the first condition or the second condition, so that you don't make mistake and use the wrong formula. And then I myself, just like we said in the first condition, for any circular arrangement, it is you that will say, okay, let this be the starting point. So let's declare blue as the start. Not just any blue, this one I just marked. Now, as I'm holding the bead and I marked here, probably the reason why I marked it is because the bead was tied at this point. You know, it is rope. Abi, it's share that thing they use is rope. Now, the rope they use in making the bead, they tie it at a point. So, using that point, let's use the point to determine our start. But then looking at the point that tied the knot is between a red bead and a blue bead. So we decided to call the blue bead our start. Now, if I turn that bead, you know, I'm holding the bead on my right hand. You can experiment this as I'm saying it. The bead is on my right palm. So as I put it on my left, this place that was start, this is where I'll be looking at as the start. Do you understand? You know, when you turn and you are facing me talking, your right will be looking as your left to me. Why? Because you are not facing where I am facing. Right? Good. So you can just experiment this at home. Just get a bead, identify a start, maybe based on color, or mark it. Then turn it by putting it in the other palm. As simple as that. You will see that that place is just like when you have the cover of a bottle in your hand. Put it in the other hand. The place that was on your palm will be the place facing up. The place that was facing up will be the part on your palm. Do you understand? So that's exactly what happens with the bead. Immediately I move it to the other hand, that blue that was the start will no longer be at this position. Remember, I chose it because of the position. So this blue will now take this position, while the red will now take this position. Have you seen how or why the red is now the start? Good. That is the reason why we have the 2 factorial in the denominator. All right, the numerator has been explained in the first condition. You've seen why it is n minus 1 factorial, because you have to determine your start, right? Which object will be the start while others form round at the back. Now, the 2 factorial below is because we have this as the start or this, depending on where the palm, where the bead is. Do you see that now? So if the bead is on my right, the blue is the start. If it's on my left, the red is the start. So in how many ways can this arrangement be done? In 2 factorial ways, which is same thing as 2. Do we understand? Now, how do we identify questions? Whenever you see a question like, in how many ways can 7 beads be arranged round, you just know that is number 2. So anything that can be turned over and the positions will change, the second condition. But if it has to do with human beings, you know, you cannot turn, you and your parents while on the dining cannot be turned. Do you understand? You cannot be turned. So you are just the first condition. Is that clear? All right, let's solve a few questions very quickly and we go over to conditional permutation. We just have our n minus 1 factorial. So what's our n? Our n is equal to 8 because we have 8 men, right? So 8 minus 1 factorial. You see how simple the question is looking, right? So this is the kind of question you get in objective under the topic permutation and combination. So we have 7 factorial, all right, which you know is 7 times 6 times 5 and so on and so forth. You keep moving down, right? Okay. The second question In how many ways can 7 beads of different colors be arranged to form a necklace? So is it the first condition or the second? You won't think twice. Beautiful. So we have 7 minus 1 factorial over 2. 2 factorial is the same thing as 2. So we have 6 factorial over 2, right? I hope you know you can cancel out here, because 6 factorial is not 6. Rather, it is 6 times 5 times 4 times 3 times 2 factorial all over 2 factorial, or 2. So these 2 will cancel out here. We have 30 times 4, 120, 120 times 3, 360 ways. Okay, so this one that wasn't completed, we have 7 factorial ways. You can actually now punch 7 factorial on your calculator. Now, very quickly, we go over to conditional permutation. Just like that, if the word must start with a vowel letter, if. So anytime you see if in a permutation question, just know that it is what? A conditional permutation. So it can come in a question that has to do with distinguishable objects or indistinguishable objects or even cyclic objects. Condition can be attached at any point in permutation. Even permutation of digits, which we will look at in the next video. So now let's sample different questions and see what questions under this conditional permutation look like. Look at, and I believe that at the end of these questions, you'll be good to go. All right, now the first one, it says, in how many ways can a family of 7 be seated round a table if the father and the mother must sit together? B, the father and the mother must not sit together. Maybe the man did not provide money for the food they are eating on that round table. So whichever one is their problem, we don't know, but the issue is we are to find how to arrange them round this table. So the second question, in how many ways can 5 students sit in a row if 2 particular students must sit at the ends of the seat or the row, right? The third one, in how many ways can the letters of the word bright be arranged if? Now, if you look at these questions, you will see that something is certain. There is always the conditional a word if. That if is what makes it conditional. Now, let's solve. The first question, it said, in how many ways can a family of 7, first of all, to arrange the family of 7 without condition, if there are no conditions attached, that's the first thing to do. Without conditions, how can this family of 7 sit round a table to enjoy their dinner or lunch? That will be n minus 1 factorial. So they are 7, so our n is 7. And that 7 minus 1, that will be 6 factorial. And 6 factorial is what? You write it. Now, if we now bring in the condition of maybe them sitting together and not sitting together, what is the next thing to do? So the first one to solve is if they must sit together. So if they must sit together, what happens? Now there are 7. 1, 2, 3, 4, 5, 6, 7. So now, if two persons, the father and the mother, are to sit together, that sitting together means, you know what God has joined together, let no man put asunder. So instead of seeing them as share, they said 1 plus 1 is 1, abi? Good. So now in that case, they are treated as 1. They are counted as 1. So while counting, we will count 1, 2, 3, 4, 5, 6. Right? Why? Because they are sitting together. So now, and as they are sitting together inside this bracket, it is either father comes first before mother, or mother comes first before father. There is an arrangement between two of them that are counted as 1. So what is that arrangement? That is 2 factorial, right? So now, how many ways can they sit together? That will be 2 factorial times, remember our n minus 1. So what's our n in this case? They are no longer 7, they are now 6. I hope you know why they are now 6, because the father and the mother are counted as 1. I also hope you know where this 2 factorial is coming from. In as much as they are counted as 1, we don't know how they are seated, whether it's father before mother or mother before father, or that's the 2 factorial, which is 2. So we'll have 2 factorial times 5 factorial, which is the same thing as 2 times 5 factorial. Now, I believe that you know that you can multiply this. This is not 5. It is 5 factorial. 5 factorial is 120. Right? Okay, so you have 240 ways. Now, the day the man did not bring money, the woman said she will never sit close to the husband. So they must stay apart. Right? Now, if you have a question that has to do with this sitting apart or staying apart, what you do is the general permutation or the normal permutation minus sitting together. So we'll have our 7 factorial minus 240. Do you understand? So if when you find your 7 factorial minus 240, that is just it. So sitting together and sitting apart is just like words and opposite. Just like if I ask you opposite of come is what? Go. Do you understand? So if they are to sit together, deduct it, minus it from the normal permutation without conditions, you will get sitting apart. As simple as ABC. So moving to the next question, what does the next question say? That's question 2. In how many ways can 5 students sit in a row if 2 particular students must sit at the end? Wow. I think that one should be the easiest. So number 2. So now 2 students sitting at the end. If this is our chair, we have here to the west, we have here to the east, right? Good. Now we have 2 students to sit at these 2 ends. Either the first student is sitting here at the west and the second student is sitting here at the east, or this person is at the west and that all is 2 factorial, right? Good. Now 2 of them must stay at both ends. Remember, we have 5 students. And out of these 5 students, it is certain that 2 students must be at the end. So what we are now doing, we have known that either this first student is here and the second student is here, or the second student is here and the first student is here. So having settled that, we are left with 3 students. Now we are to arrange the 3 students at the middle of the bench in 3 factorial ways. Have you seen why I said that's the easiest question? 2 factorial remains 2, while 3 factorial is 6, and that is 12 ways. Is that clear? All right, now moving to the third question. Let's see the third question again. Let's see it together. Okay, so the third question, in how many ways can the letters of the word bright be arranged if B and R must not be together? Unfortunately for them, from the spelling of bright, they are together. And then this time around, they want us to rearrange them such that they won't be together. Well, we don't know what the fight or quarrel is, but let's oblige them their request. So we have bright. This is the spelling of bright. Okay. Now, how many letters do we have in the word bright? That's the total arrangement of bright. We have 6 letters, so that will be 6 factorial, and we have 6 factorial to be 720. That's 120 times 6. Now, if the two R, sorry, not two R, if the B and R must be together, if the B and R must be together, that will mean 5 factorial. Why? Because the B and the R will be regarded as 1. So we'll count 1, 2, 3, 4, 5. Now, inside their togetherness, we don't know B can be first and R will be second, or R is first, B is second. That is the 2 factorial, that's all. So we have 120 times 2, which is 240. So now if the B and R are apart, we'll just have the total arrangement minus their togetherness. And that will give us 480 ways, as simple as XYZ. So moving to the next question, the fourth question. The question says, how many permutations of the word teacher are possible if the vowels must come together? So let's have the word teacher. Let's start from there. Now in this word teacher, we have, so when we remove the vowels, what do we have left? We have T, C, H, R. Now what else can you see? Well, I'm seeing E occurring 2 times. You see that indistinguishable object? Yes, look out for it at any given question that has to do with words or numbers, especially words anyway, letters, yeah. Okay, now we have 3 vowel sounds, and let's write them: E, A, E. Now remember, we want to permutate this word teacher in such a way that the vowels must come together. So in that their togetherness, we still have to arrange them. Either you have this E coming first, second, third, or E coming first, second E coming second, or just like that, which will give us 3 factorial. And then you remember that in indistinguishable objects, we'll always divide by, take the factorial of the letter that appeared more than once. E occurring 2 times will have over 2 factorial, all right, which is 3 times 2 factorial over 2 factorial. So this will cancel out, we have 3. So there are three ways of arranging or rearranging E, A, and E, right? Now, what are the other letters left? Remember, they will also be treated, right? So now, this bracket, let's have it here, and then we'll bring down the remaining consonant sounds. We have this. Okay, so now since the vowel sounds must be together, they have to be treated as one. So we have 1, 2, 3, 4, 5, and that is 5 factorial times 3. So treating them together, we're looking at 5 letters now. Then inside the vowels that must be together, we don't know how their togetherness will be. If it is E before E, or E, A, or just like that. So we know that 5 factorial is 120 times 3, and we'll have 360 ways, as simple as ABC. Now, I want to believe that with these few examples, it has made sense to you how to solve both cyclic and conditional permutation. So please, if you need further explanations or you have questions, please do well to drop it in the comment section. Like, share, follow, and invite your friends. I believe you enjoyed the video. Please join us in the next one as we look at permutation of digits with or without condition. See you in the next class. Do have a